Yes, friends. Today we are going to start electronic configuration of atoms. Okay, students, as we know that electron shells consist of one or more subshells and subshells consist of one or more atomic orbitals. So there are four subshells S, P, D and F. Now in S subshell, maximum 2 electrons can be accommodated, and in P subshell, maximum 6 electrons can be accommodated. In D subshell, maximum 10 electrons can be accommodated, and in F subshell maximum 14 electrons can be accommodated. S subshell has only one orbital, P subshell has 3 orbitals, D subshell has 5 orbitals, and F subshell has 7 orbitals. In each orbital maximum 2 electrons can be accommodated. Okay students, now these P orbitals are same in energy. These 5d orbitals, these have same energy, and these f orbital, these have same energy. So those orbitals which have same energy are known as degenerate orbitals. Degenerate orbitals. So let's start our today's topic, electronic configuration. Basically, electronic configuration is how the electrons can be distributed among the various atomic orbitals in any atom. So we write electronic configuration with numbers and letters. So this number denotes principal quantum number, and this letter denotes azimuthal or angular momentum quantum number, and this number, it tells us about the number of electrons in this orbital. We can also represent electronic configuration in the form of orbital diagram. Okay friends, for writing electronic configuration there are many different ways, but here we use a triangle method. So it is energy level diagram. It's very easy to draw. So first draw triangle and then arrows, 6 lines from left to right, and left side all s orbitals and right side p orbitals. And these lines should be diagonal, inclined. And after 4s there should be a 3d orbital. So 3d, 4d, 5d and 6d. Before 5d there should be 4f. So 4f and then 5f. So this is energy level diagram for writing electronic configuration. Okay students, now again how to draw this energy level diagram. So you have to draw lines first from left to right, 6 lines, and then s orbitals on left side, 1s, 2s, 3s, 4s, 5s, 6s and 7s, and right side p orbitals, 2p, 3p, 4p, 5p, 6p and 7p. After 4s there should be 3d orbital, then 4d, 5d, 6d. Before 5d orbital there is 4f and then 5f orbital. Okay students, so how to fill the electrons in these orbitals? Filling should be started from lower energy to higher energy. So those orbitals which are present at lower level, they have lower energy, and those orbitals which are present at higher level, they have higher energy. Okay, so we shall start from 1s2, and then 2s2, then 2p6, 3s2, 3p6, 4s2, step by step. Okay, so calcium. First find what is the atomic number of calcium. From periodic table, its atomic number is 20. So number of electrons in calcium, 20. So again, let's draw our energy level diagram. Okay, now complete electrons. Start from lower energy level to higher energy level. So 1s2, 2s2, 2p6, 3s2, 3p6, and 4s2. So when we write it in notation form, so this is electronic configuration for calcium. Let's have another iron. Its atomic number is 26. So draw energy level diagram. Left side all s and right side p orbitals. And then after 4s 3d, then 4d 5d 6d, and before 5d 4f, and then 5f. Okay, so let's start electrons. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, and 3d6. Okay students, this is the electronic configuration for iron. So we can use this energy level diagram for writing electronic configuration of any element. Now here we have some more examples. Potassium 19. When you use energy level diagram, it will be 1s2, 2s2, 2p6, 3s2, 3p6, 4s1. And zinc, atomic number 30, so 30 electrons. So similarly, use energy level diagram and you can write. And titanium 22, so use energy level diagram, you can easily write. Okay friends, this is one method. We have also one direct method, is by using periodic table. We have discussed in chapter number 2 about blocks of elements in periodic table. There are 4 blocks. S block, first 2 groups. P block, last 6 groups. D block, 10 groups in the center. And F block. Okay, now how we use this periodic table to write electronic configuration. Okay students, let's have an example of oxygen atom. Oxygen atom is present in p block elements, so last electron will be in p orbital. So when we see first shell is complete in this case, so we write 1s2 because first shell contains only one subshell, that is 1s. So 1s2 will be completed. Okay, now in second shell we have two subshells, 2s and 2p. Now 2s is also complete. When we see here, it is 2s, 2s elements, so 2s2. Now oxygen atom is present at P4 level. So we say 2P4. So what is the correct electronic configuration for oxygen atom? 1s2, 2s2, 2p4. Okay friends, we can use this method to write electronic configuration for any atom. Okay, but now let's discuss condensed method to write electronic configuration. What is condensed method? In condensed method, basically we use noble gas. Okay, how we use this one? Let's discuss electronic configuration for sulfur. Now sulfur present in p block elements. Now for writing electronic configuration for sulfur, we have to find which noble gas is present before sulfur. Here that is neon. Okay, so after neon, which orbital present? 3s. So it is also complete. So first we write neon in brackets and then 3s2, s present at p4 level. So 3p4, because it is in third shell. So third shell contains two subshells, 3s and 3p. Okay, so it will be 3p4. Now when we write sulfur atomic number 16, so just write neon and after neon 3s2, then 3p4. Okay, let's have another example, that is barium. Okay, now first to find which noble gas is present before barium, that is xenon. Okay, after xenon, which orbital? That is 6s. Now barium is present at 6s2 level, so we shall write xenon in bracket and then 6s2. So for barium, xenon and then 6s2. Okay, let's have another example, manganese. Now for manganese, we have to find which noble gas is present before manganese, that is argon. Okay, and after that 4s orbital present, it is also complete. So 4s2. Now it is present in d block elements, so last electron will be in d orbital. Okay, so at which position this manganese is present? It is d1, d2, d3, d4 and d5. So 3d5. Okay, so what is the correct electronic configuration for manganese? Argon, then 4s2, 3d5. Okay students, so this is the method to write electronic configuration for any element. It's the simplest and the easiest method. For writing electronic configuration, we have to follow these rules. First is Pauli exclusion principle. Pauli exclusion principle says no two electrons in any atom can have the same four quantum numbers. In other words, in any orbital, two electrons must have opposite spin. Now, here we have two orbitals. So, which one is stable? The first one. Second one is not favorable. Now, second is Aufbau principle. Now, according to Aufbau principle, we have to fill those orbitals which have the lowest energy. So, in other words, lowest energy orbitals fill up first. So, we have to go from down to up, step by step. 1s2, 2s2, then 2p6, 3s2, 3p6, 4s2, 3d10, 4p6. Okay, students, the third rule is Hund's rule. Now, before going to this rule, let's have one example for nitrogen. Now, there are 7 electrons in nitrogen, so we can write its electronic configuration 1s2, 2s2, 2p3. Now, in p orbital, we have two options. One is all these electrons with same spin in separate orbitals, or in second option is two electrons are paired and one is unpaired. Which is the stable one? The first one. This one is the stable one. The second one is unstable. So what is Hund's rule? Hund's rule says if there is an empty orbital available, so electrons will stay separate with the same spin. Again, If empty orbitals are available, then electrons will prefer to stay separate with the same spin rather than stay together with opposite spin. Let's discuss paramagnetism and diamagnetism. Paramagnetic substances are those substances which are attracted by a strong magnet, and diamagnetic substances are those substances which are repelled by a strong magnet. How we know this substance is paramagnetic or this substance is diamagnetic? So paramagnetic substances are those that contains net unpaired spins and are attracted by strong magnet. Now here you see there are unpaired electrons. So those substances which contain unpaired electrons are paramagnetic in nature. Okay students, in diamagnetic all electrons are paired. So these substances don't have unpaired spin. So we say these are diamagnetic. So very simple and easy. If unpaired electrons are present, it means this substance will be paramagnetic. If unpaired electrons are present, it means the substance will be diamagnetic.